Good afternoon to all of you. I, Akash Sharma, on behalf of MIDAS IT, welcome you all to this webinar on short excavation analysis. Talking today about the workflow, first of all, I would be giving a brief introduction about deep excavation, the need for retaining structures and their types. Secondly, the design process, like what is the difference between the conventional method and numerical method, and the consideration which one should consider while doing the numerical modeling. Finally, I would be doing a demonstration for the 2D modeling of short excavation, and due to time limitation, I would just introduce you to the 3D modeling in GTS NX. Deep excavation. Now, excavating deep for foundation or underground structure is very common nowadays for withstanding tall buildings or for metros. Now, improper design or improper construction failure often leads to the failure of deep excavations, which results in heavy loss to life, property, and also increase the time duration for your projects. Now, what is the solution to the problem? The solution to the problem of deep excavation collapses use of retaining structure, their proper analysis and design. Now, for proper analysis and design, one should be able to properly simulate the initial stress condition and also the loading condition which the retaining structure is going to face during the construction period. Now, the types of retaining structure. The complexity and the uncertainty involved in design and analysis increase with the degree of soil structure interaction and thus depend on the type of retaining structures to be employed. For example, first of all, we have the gravity walls. Now, the soil structure interaction is relatively simple and the stability totally depends on the normal and shear stress developed at the base. Secondly, we have the anchored earth walls. Now, the internal stability of this kind of walls relies on a complex interaction between the soil and reinforcing elements. So, soil structure interaction becomes very important to consider and hence one should go for numerical modeling. Now, third is the embedded walls. Now, the stability of the walls rely on the resistance of the ground below the excavation level and on the resistance provided by any props or anchors which are used. Now, the soil structure interaction becomes very important to consider. Now, the various type of embedded walls which we have are embedded cantilever, propped cantilever or anchored cantilever. So you see that as the interaction or the soil structure interaction becomes important, one should go or one should consider numerical modeling to take into account the soil structure interactions. Now, the design process or the conventional method. Now, first of all, we need to select the type of lateral earth pressure that are expected to work on the wall. It could be at active pressure, passive pressure or at rest. Now, one also need to consider the water pressure in case of poor drainage site, and one should multiply the pressure by factor of safety as directed by code to consider the same. Now, the second thing we do is we apply the external stability check to ensure the overall stability of the shoring system. For example, we have the factor of safety against sliding, that is, it's a ratio of the resisting horizontal force to the driving horizontal force. Now, a minimum of 1.2 is required to ensure external stability. Now, the second is factor of safety against overturning. This is simple as before, like resisting moments divided by driving moments, and a minimum of 1.5 is required to ensure the overall stability from the point of overturning. So these are basically the two checks. Now, the third thing is we need to determine the bearing capacity of the wall, which becomes very critical if the wall is based on soil and not rock. Also, the bearing stresses on both the heel and toe need to be checked, and the bearing stresses need to be checked against the permissible bearing stresses with a minimum factor of safety being 3. Now, if not possible, the settlement control becomes very critical. Now in the conventional method, we also check against failure for like loss of overall stability, the sliding failure, overturning failure, which we have already discussed, and the bearing capacity failure. Now, caused due to the failure of soil below the retaining walls, and which is very common in regions with weak soil strata, should be considered, and numerical models becomes very important at such sites. Also, one needed to check the shoring system for the structural stability. For this, one should know the accurate forces which are coming in the members for their optimal design, for the section size, reinforcement and length to be considered. So in such situation, the numerical modeling becomes very, very important. Next, let us see what's the difference between the conventional method and the numerical method. So talking about the earth pressure in design process, so the biggest difference between the conventional method and numerical method is application of earth pressure. Now in the conventional method, engineer has to calculate the earth pressure and then apply the earth pressure on the wall and check it for various factor of safeties. So this kind of simulation is very good for shallow excavation. But the numerical model, engineer need to create the mesh set for ground and wall, then define their property by various constitutive model. Then the stress and strain are calculated on the basis of constitutive model, and then after analysis the engineer obtain the stress or the earth pressure on the wall which is going to act. So this type of analysis or this type of numerical approach becomes very much important for deep excavations. Now, what are the various considerations one need to consider while doing the numerical modeling? First, it is important that the correct boundary conditions as for displacement, pore water pressure and loads are applied in any analysis to ensure proper results and safety of the retaining wall or the shoring system. First of all, the modeling type. Now, as we all know, in reality, all the geotechnical problems which involves the retaining structures are three-dimensional. But when you are simplifying your problem, assumptions made should be properly checked and taken care of. MIDAS provides with two solutions, that is MIDAS GTS NX for the 3D simulation and MIDAS Soilworks for the 2D simulation of such kind of problems. Next is consideration of assumption. Now for two-dimensional and axisymmetric analysis, the assumption is frequently made that there is an axis of symmetry about the center line of an excavation and that only half section need to be modeled in an axis of symmetry. But as you can see that if your assumption gets wrong, the displacement in the two wall could be very much different. As you can see in the right hand figure that this is the displaced shape of the walls of a road tunnel, which was, if considered to be axisymmetric, could lead to absurd results for both the walls. So you should always take care or always consider the criticality of your assumption whenever you are going for 2D modeling. Now next is the geometry of the finite model. Now next decision comes that when performing numerical analysis, what is the choice of the depth and lateral extent one should consider for the model. First of all, talking about depth. Now soil stratigraphy often provides an obvious location for the depth, as for example some hard or stiff rock coming at the lower layer. And now since the soil stiffness and strength increases with depth, analysis are not sensitive to the location of bottom boundary until it becomes very close to the bottom of wall. So as such, for depth, one shouldn't go for a depth which is very much close to the wall to ensure proper results. Now next is the lateral extent. Now as the excavation is symmetric, the position of the left hand boundary of the mesh is fixed, and for the right hand it is more problematic and depends on the constitutive model. For example, you can see that in this particular case, for elastic constitutive model, the right hand boundary was set for three different lateral extent. One was 100 meter, 52 and 36 meter, and you can see that it do affect the results. Now the next thing one should consider is the constitutive model. MIDAS provides with various constitutive models, but you can see that here I have highlighted two constitutive model, which is Moore column and modified Moore column, and it is more often used to consider the shoring excavation constitutive models. Also, if you are dealing with clay, so you can use the advanced hardening models like modified camp clay. Now talking about these two models, now for whenever you want to consider the soil shear failure, one should consider the Moore column, and one use the equivalent linear stiffness for compaction or the unloading behavior. Now if you want to consider the nonlinear compaction and the shear failure, you have to use the advanced models such as the hardening models, which includes modified Moore column and modified camp clay models. Now the applications, so Moore column is basically used for stability analysis of slope, soil structure bonded failure, and excavation problems for basic behavior. Means which are of less depth or where you just want to understand the basic behavior. But if you want to understand the behavior of deep excavation in detail, you need to go for the hardening models as discussed, like modified Moore column or modified camp clay models. Now the next thing, whenever you are doing the numerical modeling, the other important parameter is the initial ground condition. Now whenever there is excavation, the loading of the structure depends on the stress changes which are associated with the process. So it is very important that these stresses are estimated accurately at the beginning so that the changes which will happen during the process give us good results. So the second case which comes out of a result are the modified ground condition. Now consideration of the nearby structures becomes very important because they do changes the stress variation in the model. For example, if you have a tunnel, if you have very close buildings, so the effect of them in the initial stress variation of the ground should be considered. As you can see that there were two cases, one with tunnel and without tunnel. So you can see the change in the horizontal displacement of the wall. Also in the demonstration part, I will show you how much percent does it could affect your results. So one should always take care of the initial ground or the modified ground condition, as the whole analysis is associated with the stress changes, and to determine accurately the results, the initial stress condition should be properly initialized. So one should take care of that. Now next is the construction method. So one should properly simulate the construction method. One could not very much accurately but one do the same, but one should be able to simulate the construction method because the construction method do affect the results. And finally we have the groundwater control. Now at many locations dewatering becomes very much important, and one should be able to simulate the same while considering the numerical analysis. So now I'll move on to the demonstration part. In the demonstration part today I'll be taking a 2D modeling of a simple excavation in which I'm going to do two excavation sequence, excavation 1 and excavation 2. The shoring system which I'm considering consists of a retaining wall with anchors. I'd also be showing you, like, if you want to pre-stress your anchor, how one could do that. And I have an existing pipe. So I would be initializing my stress condition considering the pipe, and I will see the effect with and without consideration of this pipe for my initial stress initialization. So I will just open Soilworks for you. Okay, so this is basically the interface of Soilworks. So this is the workstrip window. So whatever element or surface you create comes in this part, and this is the tab window where you have the various geometric options, modeling options, load boundaries, analysis design, results. Now you can I will just import a CAD file, so you can directly import any CAD file which you have created. Also, if you have AutoCAD installed, you can directly copy and directly paste in the Soilworks work window. Okay, just to save time, let me import already defined ground material properties. So if you have already created, let's say, a model and you want to use the same property, you can just import the whole data from that file. So let us see what are the various material property which we are going to use. So model, ground material property. So we have alluvial layer. So I am considering the more column constitutive model for the same. We have weathered soil and weathered rock with the various parameters. Similarly, in the structural property, we have the pipe. I'll just delete the interface property because we'll create it. We have the pipe, which is basically the existing pipe with the element type defined as beam. We have the anchor, which is defined as embedded truss, and we have the pipe, which is defined as a beam type element. Okay, so now let me show you how easy it is to work with Soilworks. First of all, you can see that in the property, all the ground material property and all the structural property are in blue color. Blue means they are still unassigned. Now let us start with the structural property. So just select the pile and just drag and drop, so it gets assigned. Similarly, just select, I'll just undo it. First of all, let us intersect our curve so that it becomes helpful for definition. So go to geometry, select all and press enter. So just to intersect the various curves, and I'll just delete the interface property. Okay, so just select the curve, just drag and drop, and it gets assigned. Similarly, select the anchors, drag and drop the properties, it gets assigned. Similarly, select the pipe, which will be defined as a beam element. Just pardon me, I have to reassign it because I assigned it to pipe. So I'll just undo it. So if you want to, all the AutoCAD commands works with Soilworks, so you can just use Ctrl Z. So H pile beam. So this is our pipe, and the rest of the curves we'll select it as embedded truss. Now to assign the soil properties in Soilworks, you need to create surface. So go to geometry, click on smart surface, and the surface is automatically generated for your model. Now to assign the properties, just select the surface. So blue color means it gets selected, drag and drop. Similarly, select the other properties and assign the different ground material property. So this is our alluvial layer. Now next thing is meshing. So to mesh, Soilworks provides with the option of smart mesh. So just click on smart mesh. So in addition to smart mesh, you will find that you have other options like auto mesh, map mesh, grip mesh. So if you want to manually control, you can do that. But with smart mesh function, the program automatically generates the optimal mesh for your model. So just select the refinement. You have just to define like very fine, fine or coarse mesh. So like very fine mesh. And if you want to consider only triangular elements, so generate triangular elements and just click OK. So the program automatically generates the mesh set for your model. Okay. Now let me show you the mesh sets which we have generated. So you will see that we have different mesh sets and the name of the properties which were assigned to them. So if you just uncheck check, you can see that which of the properties or which is the layer for that particular mesh set. So our top layer is alluvial layer. So you can see that this is basically my soil inside the pipe. So I will just name it as inner pipe so that I can deactivate it at the time of construction stage definition. And this is my excavation 1. So just press F2 and you can just write the name as excavation 1. So this basically would help at the time of a definition of construction stage. And similarly, we have weathered rock and we have weathered soil 1. So this is my excavation 2. Excavation 2. Now, if you see that a single mesh set is being created by the program for the embedded truss. So let's suppose if I want to activate my nail in a one layer and the other nail in the next layer, so it would be very difficult for me. So for that, what you need to do is that you just go to model, in the option create element. What you can do is that you can just create different element from the same mesh set. What I mean to say is that just let the name as pre-stress 1. So my element type is embedded truss. So the structural property automatically comes as anchor. Now select the first point and click on the next point. So you can see here that the pre-stress 1 has been created. Now let the next part be grouted 1. So you just click on the end point and just close it. So you can see that two separate mesh sets have been generated. So activation deactivation becomes easy at the time of construction stage definition. Similarly, let us create it for the second pipe. So model, create element, let it be pre-stress 2. Now the element type being the embedded truss. So structural property automatically comes. Now click on the first part and the second part which you want to act as the pre-stress part, and let the other name for the other part be grouted 2, and okay. Close. Now if you would have activated both the nails in a single go, you need not create these nails separately. You could have directly activated this mesh set, which is the embedded truss. So both the nails would have been activated in a single go. So this is basically my modeling part. Now let us generate the boundary condition. So Soilworks provides with a smart support function. So go to loads boundaries, click on smart support, just let the name being ground support and just click OK. So the program automatically generates the boundary conditions. Now if you want to generate your own boundary conditions, so you can consider the same load boundaries and you have the option support. So you can just select the curve and node and directly assign. And as you know that in 2D, the boundary definition is not a very difficult task, but like when you have to change the model at regular intervals, the options like smart support becomes very helpful. So now having defined my ground material properties, structural properties, then the meshing for the model and generated my boundary condition, now I'd go for the construction stage definition. So go to analysis design, go to construction stage. Now you can see that there are various options. So here in the first option, you have to define the analysis type, so nonlinear static analysis. What are the number of stages you want to consider? So the number of stages, let it be 4. So you can just make it 4 and just click OK. Okay, so this is construction stage 1, 2, 3 and 4. So let us name it so that it becomes easy to understand the various steps. So first is the initialization. Initialization is basically the initial step where all the ground material properties would be activated, and we want to just initialize the stress condition in our model. Now the second is installation of structures. Installation of structures is basically we'll activating our pile and pipe elements. So we'll be initializing the displacement once again to understand how the stress is changing, or stress has changed as a result of the construction of the pipe. So initialize displacement, so modify. The third one is excavation 1. So modify, and the last one is excavation 2. So modify, close. Now let us generate the interface element for the pile. So model, and here we have the option called the interface element. In the interface element method, just make it to create from truss beam elements and select the 1D element. So just move your cursor from right to left and just select that particular element. Now if you have the defined property, so you can define the normal stiffness, the shear stiffness, or you can directly use the property wizard where you just need to define the virtual thickness factor, so let it be 0.5, and the strength reduction factor, which should let it be for now 1. So just click OK, and let the interface name being interface. So addition of mesh shed for interface element, it would be helpful for definition during the construction stage definition. So just click OK. So we have 3 interface mesh shed. What is interface link? So this is basically before initialization, before you have installed the pile, so how the nodes were connected, and after that we have interface left and interface right. So I'll be showing you how to use these elements in the construction stage definition. Now moving on to the construction stage definition. So let us define the construction stage. So first is initialization. Initialization is basically you have to drag and drop. So in the activated data at the current stage. So this is basically the data which should be used in the analysis. So whatever you activate, it would be used in the analysis. So what we need to do is we need to activate all the soil layers. So you kindly notice that inner pipe is still a soil mass. So I have activated it. And similarly we have the weathered rock. So we have weathered rock. So these are basically my interface, the pre-stress elements, the truss elements, the beam elements, and these are basically my soil elements. So activate the ground support and self-weight. So just click apply. In addition, we have also to activate the interface link so as to define the behavior before the activation of interface. So just click apply. Next is installation of structures. So first of all, we would deactivate our inner pipe, which is basically the soil pipe, soil mass inside the pipe. Now with this, we have to activate our pipe. So just activate the pipe. And similarly, we will activate our pile with the interface left and right. Sorry, just we need to activate it. So click apply. Now the next is excavation 1. So excavation 1, you just need to deactivate the mass shed so that it is removed, and you have to activate the pre-stress 1 and grouted 1. That is our first nail. So this is what I was saying, that whenever you want to activate any particular nail in a particular mesh shed, with the smart, after creating the smart mesh, you just need to create separate elements for them. So just click apply, and let's say excavation 2. So pre-stress 2 and grouted 2, which are basically our second nail, and we will deactivate the excavation 2. So naming the various mesh shed at the time of creation helps at the time of definition of construction stage. So just click apply, close. Now let's suppose if you want to consider the pre-stressing load. So how to do that, I will just show you. So just go to loads and boundaries, and there we have the option called the pre-stressed load. So you can just name it, let's say pre-stress 1 for the first one. So the element type is stress element. So you can just click, and you can just select the first element, the axial force, let's say 220, the pre-tension, and just click apply. So you can see the symbol that it is activated. Similarly, you can define the pre-stress 2. So just select the nail for the part which you want to get pre-stress, and the rest will be acting as grouted, and the rest of the parameter remains same, and click OK. Now whenever you want to activate, so in the construction stage, just go to the excavation 1. Let's suppose you want to activate here, so you just need to drag and drop, so it will be activated, the pre-stress load. So we'll be going without pre-stressing. So just close it. Now analysis, and perform the analysis. We need to just create the analysis case. Click add. In the analysis method, select the construction stage method. Let the name being CS for the construction stage analysis. And in the analysis control, now we need to define the initial stage for stress analysis. So this will be the initialization stage, and we'll be using the K0 condition. So if you want to change the different methods, you can change it from here, and also the norm or the convergence criteria which you want to consider for your model. So just click OK, close. Now analysis, run the analysis. You can save it and just run the analysis. Okay. Now after performing the analysis, now you can see that in the initial stage, this is the various results which we obtain. In the initial stage, there is no displacement in the model because we just wanted to activate the stress. So the first stage, and in the second stage we have basically just initialized the stress, so no displacement, but you can see that the pipe element has been activated. Now let us see the various results which we obtain. So the horizontal displacement, the vertical displacement, and the total displacement. Now in the finite element analysis, the most important thing is how to extract the results out of your model, because it would be of contour shape. So how to extract the model? So I would today just show you how to obtain the various results like in tabular form or in a format which you could transfer to the Excel. So just go to results. Here we have the various options to extract results. So this is the first option. This we call as extract result. So whichever analysis case, consider whatever let's say horizontal displacement you want to consider, whichever stage you want to consider. So let us consider the third and fourth. Whichever node you is of prime concern. So you can select any number of nodes along the wall or in between the model. So you can see that selected, and you can just click on table. So you can see that the various option, and you can directly copy and paste it in the Excel format. Also, like let's suppose if you are interested in the maximum value, so you just click on the maximum value and just click on the table. So it will show you the node and the maximum value which you are obtaining for your model. So this is the first option. The second option is we call as the probe. So go to results. The second option is probe. So just click on that particular node and you can see that what is the value for that particular node. So this also becomes very much helpful to extract the results. The third option which we have is the variation along 2 points. So just click on any 2 points and you can see that how it is varying for that particular 2 points. So this is the other way to extract the results out. And finally we have the effects function. So let's suppose if you want to create any set A, and what you want to consider is you want to consider only the horizontal displacement. So click it add. So it will be added as A, and similarly we have the vertical displacement, click as add. So we have two sets A and B. Now you want to create a set where you just want to see A plus B. So this is your particular area of concern. So just click OK. Now as soon as you click OK, you can see that a function or a set A has been created, and now you can see that how it is behaving for that particular set. So since we have considered the first stage, so it is showing you the initialized displaced result. So if similarly if you want to consider for any stage and you want to consider any function, you could consider the same. So let us see what are the various results we obtain. So you can see in the excavation 1, you obtain the axial stress which is obtaining there in the nails. Similarly you obtain the axial force. Similarly if you talk about the beam element forces, you obtain the axial stress, the shear force, as well as the bending moment in the pipes. Also you obtain the pressure, that is the SXX, and the beam element being shear stress, beam bending stresses, and also you obtain the stresses in the soil as a result of the excavation. Similarly for excavation 1, and you can also see for excavation 2. Okay. So this was the modeling part for GTS NX, which today I demonstrated. Basically today I considered a simple excavation, and I have used a shoring system of retaining wall and defined as a beam element, and nails defined as embedded truss elements. Now moving on to the presentation. Now a few of the results which I've extracted and I would like to share with all of you. First is the effect of shoring. Now the unshored excavations, that you can see that I have considered the displacement of the top of the wall. So the displacement for the unshored excavation and the shored excavation was, like you can see, for excavation 1, the percentage reduction in displacement with shoring was something around 22.47%, and after excavation 2 it is like something around 36.32%. So you can see that how the shoring affects, because it is the horizontal displacement which would be finally leading to the failures into the deep excavation. So similarly, the second is the effect of anchors. Now for the same model I have considered 3 cases. First, without anchors, that is only the retaining wall is there. The second is with anchors, and the third is with anchors pre-stressed. So you can see that in the without and with anchors, the percentage reduction in the displacement with the use of anchor was something around 30% after the excavation 1, and excavation 2 it was something around 34.4%. Also, if you see the results for the pre-stressed anchor, you will find that it's coming negative in the direction. Negative means in the negative X direction, that is the anchors with the pre-stressing has pulled the retaining wall back, that is into the soil. So as such there was no pre-stressing required for this particular excavation sequence. Now next is the effect of initial ground condition. Now as you've seen in the model, we had 2 conditions without considering the pipe. So let's suppose if I would have not considered the pipe excavation during my stress initialization, and I would have run the analysis, the excavation displacement for the excavation 1, the displacement at the top of wall was coming around something around 2.21 millimeter. All the results are in millimeter, pardon, I just forgot to inform. All the results were in millimeter, and with considering pipe it is something around 2.26. So excavation 1, excavation 2, the percentage variation in displacement result is within 2 to 3%, but one should always know that it depends on the location of pipe from the shoring location and the adjacent structures from the shoring side, and it is also influenced by the type of soils which you are considering. So one should always take care of the modified initial ground condition whenever you are going or you are considering shoring excavation in numerical modeling. So this was from the demonstration part. So next I would just introduce you to 3D shored excavation. I would show you the various options which we do and how we model it in GTS NX. Okay. So this is basically GTS NX. Now let us start with the model. Okay. So this is the interface. So this is model, analysis and results. So I'll just go in the pre-processing mode. So let us see that what are the material properties which we have used. So in the material, so you can see that for the structures we have used the the model type as elastic, that is isotropic elastic, and similarly for the soil layers we have used the modified Moore column. So this is basically for detailed deep excavation analysis, advanced hardening constitutive model, as I talked to you during the presentation. Also we have considered sheet pile as a 2D, that is we have given it as a beam element, and then we have defined it as the properties of 3D pile. So Similarly, we have defined the anchors as 1D embedded truss, and similarly we have considered the buried layer, colluvium and weathering soil, which are basically the soil layers, as 3D models. Now, having meshed, the next thing is the construction stage definition. So construction stage definition is very similar to what we have seen. We just need to define the activated and unactivated data. So go to the construction stage, define construction stage. So first we have the foundation, that is only all the soil mesh sheet is in the initial ground condition. Then we install we can just see it. We'll just activate. Okay, so I will just show you the activated data. Now second, we are doing the first stage excavation. So you can see that we have doing first stage excavation. Similarly, the second stage excavation and third stage excavation, and we are going on activating the supporting condition. Now to have a better look at the supporting condition, what I will do is that go to property. In the 1D, I will just activate the 1D elements. So 1D elements, basically we define it as 1D elements, but we give the property as 3D elements. So it reduces the number of elements and helps in quick analysis. And also, like if you are let's say defining the piles, so the results which we are interested are the bending moment. So you need to define the property as beam element so as to obtain, because if you go for solid modeling, you will just obtain the stress and strain and you will not obtain any bending moment as such. So in the mesh sheet, if you just uncheck few of the mesh sheet, so you can see that how actually the stiffness will be calculated by the program. So we have this I sections. So if you uncheck it, it will just be a line element for you. So but we have defined or given it as the properties. So thus you can obtain the results. And similarly, we have defined the retaining walls as 2D element. For the detail of this model, you can refer to our online YouTube channel where you can find the whole completed model. So just because of time limitation, I am just showing you the process which we obtained, which is very similar to what we did today. So these are the various elements. Now, after defining the same, I would like to show you the anchoring modeling wizard which we have in GTS NX. So you can see in GTS NX you have 2D and 3D. You just need to input the start location, the direction method which you want to obtain, the angle, the ungrouted length and grouted length, and automatically it be considered for your model. So you can consider both 2D and 3D type of anchor wizard in the model. So talking about the results. So let us see the results after the stage 1 excavation. So you can see in the various type of displacements and the element forces which are coming in your beam elements. So you can see that. You can check the shear force in them. You can see the bending moment. So you can consider the various beam element forces results. And similarly in the cell forces you can obtain. These are basically my wall elements. So you can see that what are the cell element forces, similarly the bending moment in the same. So it could also be considered. So these are the basic workflow which you can see, and this is how we go for the 3D modeling. Once again, I would request you all, like if you are interested in the 3D modeling of the completely, you can refer to our YouTube channel for the complete tutorial demonstration. So moving on to the presentation, I would finally summarize what we have learned today. So we have learned the design approach, the conventional and numerical model approaches, the differences, what are the various considerations one need to consider while performing the numerical analysis, the importance of considering shored excavation, modified initial condition and anchoring, and we have seen their effects on results, that how much it would have affected our results for the demonstrated model. And fourthly, we have the 2D modeling of shored excavation with Soilworks and a brief introduction to the 3D modeling with MIDAS GTS NX and the construction stage definition consideration. So with this, I would like to thank you all, and I would request you all, and if you have any further queries, kindly feel free to contact us at techsupport@midasit.com. So